Hello, and thank you for joining me for today's lesson on properties of gases. So what's going to happen today is you will understand how pressure, temperature, and volume of a gas are related mathematically, and then you'll be able to convert between Celsius and Kelvin temperatures. So let's get rolling. So first off, gases have different properties than solids and liquids because they move rapidly in all directions. Remember, they're not contained. They don't have to be touching one another. And so because of that, they expand to fill their containers. And they spread out easily, they mix, they have low densities, and are compressible, which is unique to only gases. And they are mostly empty space. So there's not two gases touching one another, a lot of it's empty space. And this is true for all gases all the time. To describe them, we have what are called gas laws. And there are three people that looked at different properties of gases, but these describe how the behaviors of gases are changed by pressure, volume, and temperature. And so pressure is measured in what we call pascals, volume is going to be in liters, and temperature has to be in Kelvin, and we'll talk about that here shortly. But this is going to be your gas law equation, which is P1, pressure 1 times volume 1, divided by temperature 1 equals pressure 2 times volume 2 divided by temperature 2. If you're working through a question and they don't give you anything about temperature, just cross it off and go without and just do P1 times V1 equals P2 times V2. And we'll do some practice with that here. And so first off is a guy named Boyle. And Boyle looked at pressure and volume of a gas and compared them at constant temperature. So you'll notice in this diagram, he's changing the pressures and changing the volume. He's changing the volume, which changes the pressure, but he's not touching the temperature. Temperature stays the same in both cases. So he found that these properties are inversely proportional. So if the pressure goes up, that means the volume goes down. Or reverse, if the volume goes down, the pressure goes up. And so on and so forth. For example, here we have 4 liters, or 4, we'll call it milliliters, of a gas. On this side we have 2, and so your pressure goes from 1 to 2. So they reverse. They were reciprocals of one another. So pressure 1, if we had 50 kilopascals, and volume 1 was 1 liter, and my volume 2 was 2 liters, what's my new pressure? So using P1 V1 equals P2 V2. Pressure 1 times volume 1 equals pressure 2 times volume 2. I can substitute. I know that P1 is going to be 50 kPa, kilopascals. I know my initial volume is 1 liter. I don't know my pressure 2, but I know my second volume is 2 liters. And if you take 50 times 1, divide both sides by 2 liters, you're going to get your P2 equal to 25, and it's going to be kilopascals. This is how Charles' law works. So the volume went up, which means the pressure went down. One goes up, the other has to go down. Here's another practice question. So a balloon has a volume of 10 liters at a pressure of 101 kilopascals. So I have a V1 equals 10.0 liters. I have a P1 equals to 101 kilopascals. What is the new volume when the pressure drops to 43 kilopascals? So I know that my P2 equals 43.0 kPa, and I know that my V2, I don't know my V2 because what will the new volume be? I'm not sure of that one. So that's where I'm going to stop. And I have to set up my equation. So I know that P1 V1 equals P2 V2. I'm solving for V2. So to get this by itself, I'm going to divide P2 to the other side. So I get P1 V1 equals, or P1 V1 over P2 equals V2. So here's my equation. P1 times V1 all divided by P2. If I put numbers in, I get 101 kPa times 10.0 liters divided by 43.0 kPa. And so if I do this, and I get, if I take 101 times 10 and divide that by 43, I should get an answer of 23.5. So V2 is going to be 23.5. And because I use kilopascals here and here, I'm left with just liters. So that's going to be my unit there. So that's how you're going to do these questions. Here's one for you to practice. So pause this video. You have 1 liter of a gas at 101.3 kilopascals and a constant temperature. It's compressed to only 473 milliliters. So we're in milliliters and liters. They got to be the same. So remember, 1 liter is equal to 1,000 of these. So do that conversion. And what is the new pressure on the gas? So pause the video, work through this, and then hit play and you'll get your answer. And the answer on this should be 214 kilopascals. If you do the math, I hope correctly. If you got something different, check it again and then come see me, because maybe I did my math incorrectly. But this is what I came up with. Hopefully we match. That was Boyle's law. We have Charles' law as a different guy. He compared volume and temperature under constant pressure. And he found that if the pressure stays the same, if I increase the volume, my temperature also has to go up. So volume and temperature, if temperature goes up, volume also goes up. If temperature goes down, volume also goes down. And this is where it's really important that temperature has to be in Kelvin. So to go from Celsius to Kelvin, you take your temperature plus 273, the number 273. They're just 273 units apart, which isn't terrible. But all right, so we have a balloon that has a volume of 2.0 liters. So V equals 2.0 liters at 293 degrees Celsius. So I have V1, T1 equals 293 degrees Celsius. What is the new volume of the balloon if it's placed in a container of ice water at 3.0 degrees Celsius? So what is the new volume? Ice water at 3 degrees Celsius. So this has to be in Kelvin. So I'm going to add 273 units. So if I take 293 plus 273, I'm going to get a 6 and a 6 and a 5. So 566 Kelvin should be here. If I take V1 over T1 equals V2 over T2, and I solve for V2, so I'm going to take both sides times T2. I get V1 times T2 all divided by T1, which means that 2.0 liters times, I didn't change this one. Times 276 Kelvin divided by 566 Kelvin should give me an answer. So 2 times 276 divided by 566 should equal 0. So V2 equals 0.975 or 98. And this is going to be liters because my K's are going to cancel. And then your last one is going to be here. And I'll let you do this one on your own. I have the answer on the next slide. So on hot days, you may have noticed that potato chip bags seem to inflate even though they may not have been open. If I have a 250 milliliter bag at a temperature of 19 degrees Celsius and I leave it in my car, which has a temperature of 60 degrees Celsius, what will the new volume of the bag be? And so things that we know, I have a V1, I have 250 milliliters. I know my T1 is 19.0 degrees Celsius. I'm looking for, I know my T2 is 60 degrees Celsius, and I'm looking for V2. Okay, so for this, you can leave the milliliters, make sure you change degrees Celsius to Kelvin. Go ahead and pause the video, work through the calculations, and I will give you the answers on the next slide. So when I did this, I came out to 285 milliliters for my bag. So check yours. Hopefully we got the same answer. If we didn't, come see me. We'll talk through it. We'll figure out where we diverged at. But this is your gas laws. I'd like you to answer these couple questions. So, how are pressure and volume related according to Boyle's law? How are temperature and volume related according to Charles' law? And how do you convert between Celsius and Kelvin? Be sure you can answer these, and then I look forward to seeing you again when we reconvene. For now, enjoy the rest of your day, and I will see you later.